Hello guys, and welcome back to part 6 of this KNN tutorial series on Python. So in our last video we kind of finished our classifier on the top level, in the sense that we were able to split our data into training data and test data and predict some values. In this video we're going to learn a couple of things. First we're going to actually iterate through a bunch of different k values to see if we can find the best value for k for our accuracy in predicting things. And then we're actually going to talk about why what we're doing is not good and how we could make it better. So stick around until the end to find that out. So what we're going to start with now is we're going to start writing some code, and I want to find I'm going to define this variable called train length, and this is going to basically hold our k possible values. And the reason for that is, so this wants to be x train or y train, they're both the same length, so it doesn't matter. And we also want to create this array that I'm going to call the k ac scores, and this is just going to be an empty list. And we're going to come here and have a for loop, and we're going to say for k in range 1, and then we're going to do train length. So this is basically saying what values can k actually hold. Well, we could compare it to some of our training data, like 3 of our training data, or we could compare it to every value in the training data. So it could be anything from 0 to 100 with the way we split it up currently. And we're going to increment in 2 because we want an odd number. You should probably know why we want an odd number, but the reason is when we're classifying, let's say we're classifying into 2 categories, for example, and you have 2 points which are saying you should categorize this as A and 2 saying you should categorize this as B, then you don't have that final decisive vote. So we need that. So always have an odd number, and then we're just going to actually keep this exactly the same, apart from we're actually going to come over here and say, well, this is going to be k. So we're going to basically iterate through this classifier with 1, then 3, then 5, then 7, and so on. And we're going to see which k gives us our best accuracy. So we've got k ac scores, and we're now just going to append scores. And we're just going to append all of these k values. So we're going to say, I want some text, and we're going to say if k is, we're going to do little k. If k is our first placeholder, which is going to be k, then the accuracy equals our second placeholder. Then we're going to format that, and our first placeholder is k, of course, so we're saying k is blah blah blah. Then we're going to do this accuracy score function as we did before. And inside here we had 2 parameters, if you remember, and that was y test and also the pred, which is our prediction. So what we're doing now is we're filling this whole array, this whole list, with the k, the value that k actually is, and the accuracy that we get when that is our k value. So all we need to do now is come down here and print k ac scores, and that's it. So if we go back and we actually execute this Python script, we're still printing that from earlier. It's now going to take a few seconds, but there you go. We've got this bigger list now from 1 to 99, and we can actually see the first time we get 100% accuracy, and I say that with my fingers and quotation marks, which you can't see, is at k is 11. So if you were happy with that, what you could do now is you could say, look, k is the lowest value we need for our accuracy to be 100%. That is a bit flawed. We'll get to that in a second. And we can also see what's interesting is if we look at these values, when we get to 69, nice, we actually find that we drop off massively. Like, we're not even predicting a third of the data set correctly anymore. And not only are they taken longer to do, to actually compare it to 69 values, it's not even as efficient. So we would choose the value 11. Although if you're happy with 98% accuracy, you could also just go with k equals 1. Now, the reason this is flawed, of course, is because what we've actually done is we've overfitted, is what they call it in statistics. We've essentially we've optimized this model, this KNN classifier model, for our specific data set. It's not really a true test in that sense, because we've got the test data, we've got the training data, and we've used all of the test data, and we've just run our k values through until we got 100%. But it's really sort of cheating. And if you've watched any of the Stanford University lectures on computer vision, something that you need to do really in the minimum is to split your data into 3. So you'll have your train data, your validation data, and your test data. And what we would actually do is we would train our model just as before, but we would actually optimize the classifier for the validation set. And once we're happy with that optimization, it's only then would you then use this classifier for a proper test set. And obviously the best outcome would be that the accuracy is as good as the validation set that you optimized. That would be the ideal outcome. Something else we can do, which we will do coming up, is we're actually going to split the data into something called folds, where we're basically having many validation sets, and we're just going to do lots of little changes, and then hopefully we can find the optimal way in which what k should be in this instance. So if you're happy with all of that, at this point you can leave. If you're a Linux guy, because I'm not really sure how you do this on Windows, maybe you can do this on Windows just the same way. We're actually going to use this really cool, let's see where it is. We're going to use this really cool Python function that comes, where we can do, and I'll explain to you what it's doing, but it's basically going to tell us how long our program is taking to execute. And we're going to, so I'll talk you through what's actually going on here. So it's a Python command. So we've got Python 3, it's just how we would run a script. And then we're using this Python cProfile command, which comes by default with the standard Python library. And we're going to sort all of our data that we're going to receive by the come time, which is not what you think it is, it's just the cumulative time. And then we're going to push. So basically we need to push this into, we're going to do this on a.py, and then we're going to push the result into this test.py. This could actually be a text file if you want. So we're going to push the result of this, because you have to do this, you can't just print it straight to the terminal. We're going to push this result into another file called temp.py, and then using this head function, which is just a default Linux function, we're going to print the first 20 lines, and then we're going to remove temp.py. So let's just see what this actually looks like. So it took about 6 seconds, I think, when I did it before, so you can see. So what we've done is we've got the output of our Python script, and it's actually told us, look, this function made 885,973 primitive calls in 6.048 seconds. So that's the total cumulative time, and then we've also sorted by come time. So you can see that you can look at everything. You could also look at total time. We can actually look at most things as about 0 seconds. So if we actually came back to this and you wanted to sort by total time, then you should probably see that one at the top. So again, we need to wait about 5 or 6 seconds for this to be finished. And there you go. So this time we sorted by total time. So this is actually a huge file, so make sure you try to limit it with using head and only reading the first 20 lines. Depends on what you're printing as well. But yeah, we can actually see that this method acquire of thread.lock, whatever that is, that's actually taken 5 seconds. So that's the bulk of our program. And something else you can do, something that looks a bit cooler, if you've actually got bat installed instead of using cat, then our output's just going to look slightly nicer. It says the same things, but we get some nice colors. And actually, if we printed our Python file with bat, then we can actually see which line the things are happening on. So let's quit that. So you don't really need to know that, but I think it's cool. So if you're running Linux, then that's a cool little command you can run to check how quickly your program is executing. So thank you for watching, and I shall see you in the next video.